if you are managing a construction project in the Middle East right now,
Yeah.
there is a 99.2% chance your timeline is already dead.
Yeah, it's just a staggering statistic.
Right, you're delayed. That is, well, it's a virtual statistical guarantee, and it actually gets worse.
Much worse.
For nearly 60% of those projects, that delay is going to exceed 6 months. Today, we're finding out exactly why. Welcome to this deep dive.
Glad to be here.
If you are an experienced construction professional, a quantity surveyor, a project director, or just someone intensely curious about how billions of dollars of infrastructure actually get built, or I guess fail to get built, you're in the exact right place.
Exactly.
Today, we are tearing into a massive, heavily researched Master of Science dissertation by Suze Hewage, Vindana Hewage. It's titled An Empirical Study of Project Management Failures Contributing to Construction Project Delays in the Middle Eastern Region. And it is, honestly, a remarkable piece of work.
It truly is. I mean, what makes this document so vital right now is that it doesn't just rely on the usual anecdotal complaints.
Yeah. Right, the typical grumbling.
Yeah, exactly. You go to a site and everyone blames the weather or a late shipment of steel or just a difficult client. This research completely bypasses the water cooler complaints.
It gets into the real data.
Right. It provides a rigorous, data-driven autopsy of systemic failures in, well, one of the most economically critical regions on the planet.
And the stakes in that region are almost unfathomable. I mean, we aren't talking about building a local library or like a strip mall.
Not at all.
The Gulf Cooperation Council, the GCC, specifically countries like Saudi Arabia, the UAE, Qatar, and Oman, is undergoing this unprecedented monumental infrastructure expansion.
It's massive.
We are looking at national transformational agendas, like Saudi Arabia's Vision 2030, which involves building entirely new futuristic cities literally from scratch.
Yeah, any Yeoman projects of that scale.
Right. And you have the lingering infrastructure momentum from mega events like Qatar's FIFA 2022 World Cup and just the UAE's continuous, relentless urban evolution. There are billions, literally billions of dollars in capital investment online here.
Exactly. And when almost 60% of these projects are delayed by over half a year, that kind of systemic failure actively erodes international investor confidence.
Oh, absolutely.
It inflates costs exponentially, and I mean, it can actually disrupt entire national economic strategies.
Yeah, you can't just brush off a 6-month delay on a $50 billion project.
Precisely. The sheer scale of the GCC construction market magnifies every single inefficiency. A 10% cost overrun on, say, a small residential build is painful for the owner, sure.
Right, it hurts.
But a 10% cost overrun on a brand new industrial port city, that has macroeconomic implications. It ties up state capital, it delays the revenue generation of those massive assets, and it strains the entire global supply chain of materials and human labor.
Okay, let's unpack this. I want to give you, the listener, a clear roadmap of where we are heading today. We're going to start by looking under the hood at how this study was actually built.
Which is crucial.
Yeah, because when you throw around a stat like 99.2% of projects are delayed, we need to know the math is bulletproof.
Absolutely.
From there, we'll explore the theoretical frameworks the researcher used to make sense of this chaos, basically, the lenses that turn raw data into actual insight.
Right.
Then we're going to get into the dirt. We'll break down the 4 critical points of failure that are actively destroying these timelines. After that, we'll look at whether risk management can actually save a doomed project.
Spoiler alert, it's complicated.
Yeah, very. And we will confront the so-called digital dilemma, the reality of throwing high-tech software at very human problems. Finally, we'll wrap up with voices from the field and some highly actionable recommendations.
It is a comprehensive journey, and it really demands that we look at construction not just as an engineering challenge, but as a complex socioeconomic system.
Right, which brings me to my first major question about this document. When I read that 99.2% failure rate, my immediate cynical reaction was to ask, well, who exactly did they ask?
That's fair.
Because if you just poll a bunch of frustrated subcontractors on a Friday afternoon in the middle of the heat wave, of course they're going to say the project is a disaster.
Yeah.
How do we know this isn't just a highly structured venting session?
That is a completely valid skepticism, and it's exactly why the methodological rigor of this study is so important. This is an explanatory, cross-sectional, mixed methods approach.
Okay, meaning what?
Meaning the researcher didn't just stand outside a site with a clipboard taking complaints. They systematically collected 124 validated responses from senior industry professionals who are actively working in the GCC construction sector.
Okay, so these are the heavy hitters.
Exactly. The demographic breakdown is crucial here. They surveyed project managers, quantity surveyors, commercial managers, and site engineers.
So we're getting a real 360-degree view. You have the site engineers who are literally standing in the sand, dealing with the physical logistics, but you also have the commercial managers and quantity surveyors who are, looking at the cash flow and the contracts.
Exactly. You are cross-referencing the physical reality with the financial reality. And the statistical heavy lifting they applied to these responses, well, it goes far beyond basic spreadsheets.
What do they use?
They utilized IBM SPSS statistics and integrated the process macro, which was developed by Andrew Hayes.
Okay, I have to stop you there because as soon as we start dropping names of statistical software macros, my eyes start to glaze over a bit.
I get it.
For the professional listening to this while driving to a site right now, why should they care that the researcher used the process macro instead of just doing normal math?
Because the construction industry is inherently nonlinear, and basic math just doesn't capture nonlinear reality.
Okay.
In a typical, simpler study, you might just look for simple correlations. You ask, does a failure in planning cause a delay? And the math says, yes, it does.
Right, straightforward.
But that's just a two-dimensional photograph of the problem. What the process macro allows the researcher to do is conditional process modeling.
Conditional process modeling.
Yes. It lets them test complex, multiple linear regressions. But more importantly, it allows them to test mediation and moderation simultaneously.
Meaning what, in plain English?
Meaning it answers not just if a failure causes a delay, but through what exact mechanism and under what specific conditions.
Oh, I see.
It allows us to see if variable A causes variable B, but only when variable C is present. It takes the analysis from a flat photograph to a dynamic, three-dimensional model of cause and effect. It actually mirrors the complexity of a real construction site.
I see. But even with the fanciest 3D modeling software in the world, the output is only as good as the input.
Always.
If the underlying data is garbage, the insights are garbage. I noticed they spent a lot of time in the paper talking about Cronbach's alpha and Shapiro-Wilk tests.
Yes, the data validation phase.
Let me propose an analogy here. Building a statistical model is like building a skyscraper. If the foundation, which is the data validation, is weak, I don't care how beautiful the glass facade of your regression model is on the 80th floor, the whole thing is going to collapse.
That is a perfect analogy.
Yeah.
You simply cannot build a predictive model on unstable data. So to pour that solid foundation, the researcher used Cronbach's alpha, which is essentially a stress test for internal consistency.
How does that work?
Imagine you are surveying someone's understanding of a project's timeline. If you ask them 3 different questions that all fundamentally measure schedule awareness and they give you 3 wildly contradictory answers.
They're just making it up.
Right. That respondent is either guessing randomly or they just don't understand the survey.
Their data is essentially hollow.
Exactly. Cronbach's alpha measures whether the survey constructs are yielding reliable, consistent responses. If the score is low, the foundation is cracked. But in this study, the constructs proved highly reliable.
Okay, good. And the Shapiro-Wilk test.
Then they applied the Shapiro-Wilk test to check if the data was distributed normally, like your classic bell curve. Interestingly, some of the data showed non-normality.
Wait, if the data isn't normal, doesn't that invalidate the parametric testing they used later on?
In a very small sample, yes, it would be a major red flag. But because they had a robust, validated sample size of 124 professionals, the central limit theorem kicks in.
Central limit theorem.
Yes. The sheer volume of data smooths out those irregularities, making it mathematically sound to proceed with advanced parametric analysis.
Got it.
They also layered on exploratory factor analysis, or EFA, and ANOVA testing to absolutely guarantee construct validity. The main takeaway for you, the listener, is this. The foundation of this research is poured with high-strength concrete.
Love that.
The insights we are about to discuss are built on mathematical bedrock.
Okay, so the data is rock solid. But raw numbers on a spreadsheet don't actually tell us why things are breaking. You can have all the valid data in the world, but until you look at it through a specific lens, it's just noise. How did the researcher actually make sense of all this?
They applied a multi-theoretical framework. They essentially used 4 distinct academic lenses to interpret the raw data, bridging the gap between statistical output and actual human behavior.
Which is vital.
Very vital, because treating construction delays as purely technical errors ignores the human and bureaucratic environment entirely.
So this first lens.
The first is systems theory. In the context of mega projects, you have to stop viewing a construction site as a checklist of isolated independent tasks. It is not a to-do list.
Right.
It is a highly sensitive, deeply interconnected ecosystem.
Okay, so under systems theory, a delay isn't just a discrete event. Let's say you're building a massive commercial tower, and there's a problem with the materials logistics. A shipment of custom steel rebar gets held up in customs for a week.
A very common scenario.
Right. Under a traditional checklist view, you just say, okay, the steel is a week late. But under systems theory, you see the ripple effect. Because the steel is late, the concrete pouring team is standing around idle, burning payroll. Because the concrete isn't poured, the curing time is pushed back. Because the curing time is pushed, the electrical rough-in teams can't get onto the floor.
And it keeps compounding.
Right. Suddenly, that 1-week delay in customs has disrupted the scheduling of 4 different specialized subcontractors who are now threatening to pull their labor off your site and go work somewhere else.
That is the ecosystem fragility in a nutshell. A local failure cascades into a systemic failure. The second lens they use is institutional theory, which is arguably the most critical for understanding the Middle East specifically.
How so?
Institutional theory focuses on the broader environment that surrounds and pressures the project ecosystem. It looks at the regulatory frameworks, the bureaucratic governance, the legal structures, and, well, the political environments.
Which are intense in the GCC.
Very. In the GCC, you are often dealing with heavily centralized public sector or semi-government clients. The approval processes can be labyrinthine.
So we were talking about the paper trail. The permits, the environmental clearances, the visa approvals for the workers.
Exactly. You could have a perfectly engineered systems theory ecosystem on your site. But if institutional theory dictates that your client requires 3 different ministerial signatures to approve a critical design change,
Which happens all the time.
and that process takes 2 months, your project is frozen, the bureaucracy itself becomes the bottleneck.
That makes total sense.
Yeah.
You can't out-engineer a slow bureaucracy.
Hmm.
What's the third lens?
Transaction cost theory. This looks at the economic friction between all the moving parts. On a mega project, you have the client, the lead consultant, the main contractor, and perhaps 50 different subcontractors and suppliers.
A lot of cooks in the kitchen.
Exactly. Transaction cost theory examines the cost of inefficient coordination between these distinct entities.
Right. Friction. So if the architectural consultant and the mechanical engineering subcontractor don't communicate properly about the dimensions of an HVAC shaft and they have to issue a change order, that creates friction.
Huge friction.
And that friction isn't just paid for in money, right? It is paid for in time. Lawyers get involved, contracts are reviewed, work stops while the liability is debated.
Precisely. The heavier the friction, the higher the transaction cost, and the longer the delay. Finally, we have complexity theory.
Complexity theory.
Yes. This lens is specifically suited for the unprecedented scale of projects we are seeing in places like Saudi Arabia's NEOM or massive integrated rail networks across the UAE.
I've heard the term complexity theory thrown around in tech and economics, but how does it manifest physically on a construction site?
Complexity theory deals with how nonlinear, highly interdependent tasks interact in unpredictable ways. Let's build on your HVAC example.
Okay.
Imagine a change order for the HVAC routing on a multi-billion-dollar airport terminal. Under complexity theory, that change doesn't just delay the air conditioning installation. Because the ductwork moved, the ceiling grids have to be redesigned. Because the ceiling grids moved, the lighting placement changes. Because the lighting changed, the electrical loads must be recalculated, which means the municipal electrical inspector has to be rescheduled.
Let me guess. The inspector is busy.
Exactly. That inspector is currently booked solid for the next 3 weeks across the city. One minor architectural tweak on an air duct just cascaded through a dozen non-linear dependencies and delayed a $500 million terminal section by a month.
Wow. Okay, so we have these 4 lenses. The ripple effects of systems theory, the bureaucratic weight of institutional theory, the coordination friction of transaction cost theory, and the unpredictable chain reactions of complexity theory.
Yes.
The researcher took these massive concepts and essentially mapped them onto 4 specific points of failure to see which ones actually drive delays, right?
Yes, they tested 4 specific operational domains, and the multiple linear regression results are incredibly telling. They didn't just guess what was going wrong, they proved mathematically what was breaking the timelines.
So let's get into the dirt. Let's look at the first massive failure point. The study identifies this as construction planning effectiveness.
The statistical output here is stark. The beta coefficient was 0.450 with a highly significant p-value of less than 0.001. More importantly, the r-squared value was 0.202.
Which means what exactly for the person whose timeline is bleeding out?
It means that roughly 20% of the total variance in project delays across the GCC can be explained solely by deficiencies in early phase planning.
2%.
Yes. If you screw up the front-end planning, you are baking a 20% delay risk into your project before you even start digging.
Just from the planning phase. But here is what I don't get, and I really want to push back on this. We're talking about billion-dollar projects run by some of the most educated, experienced engineering firms on Earth.
True.
They have entire floors of corporate offices dedicated to nothing but planning. How do they get the front end so wrong that it accounts for 1/5 of all delays?
Because of the cultural and institutional context of the region. The literature review in the dissertation highlights a recurring theme: immense political and economic urgency.
Okay.
In many GCC nations, these megaprojects are deeply tied to national pride, economic diversification, and strict transformational deadlines. The leadership wants to see cranes in the sky. They want the public to see visible momentum.
So there's a top-down mandate to break ground immediately, regardless of whether the blueprints are actually finished.
Exactly. The urgency to physically begin construction overrides the necessity of comprehensive feasibility studies, detailed stakeholder design workshops, and rigorous front-end scope definition.
I look at it like trying to shoot a massive Hollywood blockbuster movie without a finished script. You have the A-list actors on set, you have the cameras rolling, you're burning hundreds of thousands of dollars a day in production costs. But everyone is just standing around waiting for the director to decide what the scene is actually supposed to be. And because you started shooting before the story was finalized, you are going to have to go back and reshoot half the movie later.
That is a phenomenal analogy for what happens on these sites. You go into the execution phase with a reactive, incomplete schedule. You start pouring concrete based on preliminary designs.
And then?
And then, inevitably, the client decides they want to change the layout, or the engineering team realizes the structural loads were miscalculated. Now you are issuing endless change orders. You have to demolish work you just completed.
Which brings in systems theory again.
Exactly. Under systems theory, this foundational failure echoes through the entire life cycle of the project, multiplying the delays at every stage.
Which brings us to the second major point of failure. And looking at the numbers in the study, this one is an absolute monster. Schedule control and direction.
It is indeed the strongest individual predictor of delay in the entire dataset. The beta coefficient was a massive Hamelin 619. The R-squared was 0.383.
Almost 40%. Yes.
Nearly 40% of the delay variance is explained just by how a project is scheduled and monitored once it's underway. Wait, isn't scheduling fundamentally just an administrative task?
You'd think so, wouldn't you?
Yeah. You type dates into Microsoft Project or Primavera, you assign resources, and you hit save. How does something so administrative cause a literal multi-million-dollar construction site to grind to a halt?
Because a schedule is only as good as its real-time accuracy. The research points out a fatal flaw in regional project management: the reliance on weak baseline schedules and highly informal progress tracking.
What does informal progress tracking actually look like on a billion-dollar site?
It looks like a site manager walking around with a notebook, visually eyeballing the work, and reporting back in a weekly meeting, yeah, we're about 60% done with the framing.
You're kidding.
I wish I was. It is subjective, it is prone to optimism bias, and it lacks rigorous data validation. They are not consistently using advanced earned value management or dynamic critical path method updates. So they are effectively driving blind. I compare this to navigating a massive, fully loaded cargo ship across the ocean without any radar or GPS.
Great comparison.
You set your initial bearing when you leave port. That's your baseline schedule. But the currents shift, the wind pushes you. If you are just guessing your coordinates by looking at the stars once a week, by the time you finally realize you are 5 degrees off course and heading straight for a coral reef,
It's too late.
yeah, The sheer momentum of that massive ship makes it physically impossible to turn the wheel fast enough to avoid a crash. You are going to run aground, or in this case, you are going to miss your completion deadline by a year.
And that is exactly where transaction cost theory comes back into play. When your schedule monitoring is that weak, the cost of coordinating a sudden correction becomes astronomically high.
Right, because everyone has to scramble.
Exactly. If you don't know you are delayed until the delay is already a month old, you can't just tell the workforce to work harder. You have to authorize massive overtime pay, you have to expedite shipping for materials at premium rates, and you have to renegotiate with subcontractors whose subsequent schedules are now ruined.
It's a nightmare.
It is. Without real-time, data-driven direction, management teams are perpetually reacting to yesterday's crises rather than mitigating tomorrow's risks.
And all that reacting, all that overtime and expedited shipping drains the bank accounts, which perfectly segues into the third point of failure: project finance management.
A critical issue.
The stats here are significant. A beta of 0.499 and an R-squared of 0.249. So roughly 25% of the delay is tied directly to the money.
Money is the oxygen of a construction site. If it stops flowing, the site suffocates instantly.
Right.
If we look at this through the lens of institutional theory, we have to examine the unique financial landscape of the Middle East construction sector. There's a very high concentration of public sector and semi-government clients.
Meaning the government is usually the one footing the bill for these mega projects.
Correct. And while state-backed projects offer massive scale, they also come with highly complex, deeply layered bureaucratic frameworks for releasing funds. The payment cycles can be incredibly lengthy.
Just to get a check cut.
Exactly. An invoice might need to be verified by a consultant, approved by a project manager, audited by a governmental finance department, and then finally authorized for release.
And meanwhile, the region's historical dependency on oil and gas revenues creates this layer of macroeconomic volatility, doesn't it?
Absolutely.
If the global price of crude oil suddenly dips, state budgets are often rapidly revised. Infrastructure capital can get locked up or delayed while ministries reassess their quarterly spending.
Exactly. And the implication on the ground is immediate and devastating. So if the client delays payments to the main contractor freezes.
But what happens to the thousands of workers standing on site when the money stops flowing?
The cascade is brutal. The main contractor stops paying the specialized subcontractors. The subcontractors, who are already operating on razor-thin margins, immediately stop procuring materials because they can't afford the upfront costs.
And if it goes on too long,
If the delay persists, those subcontractors will physically withdraw their labor force. They will pack up their tools, load their workers onto buses, and move them to another site that is actually paying them.
so a financial bottleneck translates instantly into an operational freeze.
Yes. And getting that momentum back is incredibly difficult. Once a subcontractor leaves your site, you can't just snap your fingers and get them back the day the invoice is finally paid. They have committed their resources elsewhere.
Right, they've moved on.
This isn't just about sloppy bookkeeping. It is about severe liquidity crises driven by underdeveloped risk allocation in the financial contracts.
Which perfectly sets up the final and perhaps most human point of failure. The fourth operational domain they tested was labor and resource management.
Yeah.
And the numbers here are massive, too. A beta of 0.582 and an R-squared of 0.159. Labor management is a huge driver of delays, right behind schedule control.
To understand why this variable is so powerful, you have to understand the sheer mind-boggling human logistics of building in the GCC. You are not just hiring a local workforce from the town over.
No, not at all.
The construction sector in the Middle East is overwhelmingly reliant on transient, expatriate labor, primarily drawn from South Asia, Southeast Asia, and parts of Africa.
Right, so you aren't just managing the construction of a building, you are managing a complex international supply chain of human capital.
Exactly. Think about the logistics involved before a worker even picks up a hammer. You are dealing with international recruitment agencies. You are navigating shifting visa policies and immigration quotas.
And a kafala system, right?
Yes, working within the framework of the kafala sponsorship system. You have to arrange massive labor camps, transportation logistics, to move thousands of men from the camps to the site every morning.
It's like moving a small army.
It really is. And you are doing all of this under incredibly harsh climatic conditions, with summer temperatures regularly exceeding 110 degrees Fahrenheit.
That alone is a logistical nightmare. But The study also points to issues happening actually on the site, doesn't it?
Yes, because once you get those thousands of workers onto the site, you face massive communication barriers. You might have a site where the workforce speaks a dozen different dialects of Hindi, Urdu, Bengali, Tagalog, and Arabic.
Wow.
The foremen and site engineers struggle to communicate complex safety or structural instructions efficiently.
And the dissertation also highlights severe skill mismatches, right?
That is a critical point. The rapid, unrelenting pace of infrastructure expansion in the region demands highly skilled, specialized labor, but the supply chain often delivers semi-skilled or unskilled workers.
So what does that actually look like on site?
It looks like lower productivity rates. It means tasks take twice as long to complete as the baseline schedule predicted. It means higher error rates, which inevitably leads to rework.
Give me an example of rework.
Say a crew incorrectly ties the rebar for a column because they misunderstood the structural drawings or just lacked the specific training. The consultant will fail the inspection.
Right.
The crew then has to spend 2 days undoing the work and redoing it. Under complexity theory, managing thousands of workers from diverse backgrounds under extreme heat with varying skill levels and communication barriers creates a highly fragile operational web that is incredibly prone to schedule slippage.
Okay, let's take a breath and look at the whole picture here. We have poor front-end planning, blind real-time scheduling, frozen financial supply lines, and an incredibly complex multinational labor force struggling with skill mismatches.
It's a lot.
It's huge. And just to prove that these aren't just isolated complaints, the researcher ran ANOVIA testing, correct?
Yes, and the F statistics were highly significant, ranging from 30.9 to 75.6 across the models.
Meaning what for us?
This proves definitively that these 4 pillars of failure are deeply intertwined, statistically proven systemic drivers of time overruns.
So we have diagnosed the disease. We know exactly what is breaking the projects. But projects don't just sit there and let themselves be delayed. Project management teams actively try to fight back.
They do.
And that brings us to the concept of risk management.
Yes. The researcher didn't just ask what causes the delay. They asked if the management practices designed to stop delays actually work. They tested risk management as a mediating variable.
Let's clarify how that works conceptually without getting bogged down in the math. What does it mean for risk management to act as a mediator?
It means we are testing a sequence of events. Does poor planning directly cause a delay? Or does poor planning overwhelm your risk management system, which then allows the delay to happen?
Okay.
Conversely, if you have poor planning but you implement a truly spectacular risk management strategy, can that strategy absorb the blow and prevent the delay from materializing?
Right.
The researcher used advanced mediation analysis, generating bootstrap confidence intervals to see if this buffering effect was actually significant.
And here is where it gets really interesting to me. The findings present this incredibly nuanced, almost contradictory truth. It isn't a blanket statement that risk management saves the day.
Not at all.
According to the data, risk management works beautifully as a buffer for planning effectiveness and project finance management. But it completely fails to buffer schedule control or labor management.
It is a fascinating divergence in the data.
I need you to explain this to me. Why does risk management fix the money and the planning, but totally fail to save the schedule and the workers?
To understand this, we have to look at what risk management actually is in daily practice. When it comes to planning and finance, risk management acts as an intellectual and strategic shield. It is proactive.
Okay, give me a scenario.
Let's say you have poor initial planning. The design is a bit rushed. But you implement robust dynamic risk registers, you hold weekly risk mitigation meetings, you run continuous clash detection on the designs, and you develop strong contingency plans.
So you're catching things early.
Right. Because you are actively managing the risk before the physical work occurs, you can catch the design flaws while they are still just lines on a blueprint before they become concrete poured in the wrong place.
And the same applies to the money.
Exactly. If you foresee that your public sector client has a history of lengthy payment cycles, a strong financial risk strategy can save you. You secure a revolving credit facility with a bank beforehand, or you negotiate advance payment guarantees and front-load your cash flow.
Oh, that makes sense.
You build a financial shock absorber so that when the client's payment is delayed by 60 days, your site keeps moving because you have the liquidity to pay your subcontractors.
So it buffers the intellectual planning and the financial strategy. But what about the physical reality on the site?
That is exactly where it breaks down. Risk management is fundamentally a proactive tool for forecasting. It is not a retroactive cure for a physical operational collapse that is already occurring in real time.
So if your baseline schedule is already fundamentally broken and you are flying blind without radar, a risk register isn't going to help you.
Precisely. You can have the most beautiful, color-coded, heavily audited risk register sitting on the project director's mahogany desk,
Right.
but it does absolutely nothing to fix the fact that you are short 500 carpenters on the 40th floor because their visas were denied.
Yeah, a spreadsheet can't build a wall.
Exactly. If your workers lack the necessary skills to pour complex architectural concrete, identifying that risk on a spreadsheet doesn't magically bestow them with 10 years of specialized experience.
Wow.
For schedule and labor, the failure is intensely physical and operational. Risk management cannot lay bricks faster.
That is such a vital distinction.
Yeah.
You cannot risk manage your way out of an empty construction site. It's a strategic tool, not a physical one.
Exactly.
So if human risk management has its physical limits and we are still staring down a 99.2% delay rate, everyone naturally looks for a silver bullet.
And we all know what that usually is.
Right. In the 2020s, that silver bullet is always technology. Let's talk about the so-called digital dilemma. The researcher looked at digital construction technology, things like building information modeling, BIM, Internet of Things sensors, and artificial intelligence to see if they could act as a moderating variable.
Yes. And testing for moderation asks a fundamentally different question than testing for mediation.
How so?
It asks, does the presence of digital construction technology change the strength or the direction of the relationship between the management failure and the delay? If we throw high-tech software at a bad schedule, does the bad schedule suddenly cause less delay?
And the data presents this fascinating tension. When I first read the abstract of the dissertation, it sounded incredibly optimistic.
Yes, the abstract paints a rosy picture.
Right. It noted that digital construction technology significantly moderates schedule control and financial management. The stats show it works. But then, I flipped to the conclusion of the study, and there is this stark, explicit warning.
The caveat.
Yeah, the caveat. It reads, and I quote, "Digital construction technology did not significantly moderate the relationships, indicating that technological tools alone are insufficient without institutional and behavioral readiness." So I am confused. Which is it? Is the technology working? Or is it failing?
What you are seeing is the gap between mathematical potential and ground-level human reality.
Okay, unpack that.
The statistical models show that when digital tools are fully present and utilized perfectly, they have the mathematical potential to drastically alter the trajectory of a project.
How so? Give me an example.
Think about what a 4D or 5D BIM model actually is. It isn't just a 3D drawing. A 4D model integrates the physical dimensions with the project schedule. A 5D model integrates the dimensions, the schedule, and the cost.
Okay, that sounds incredibly powerful.
It is. If you have a fully integrated 4D BIM schedule, you have absolute real-time transparency. If the mechanical contractor is 3 days behind on installing the ductwork, the software instantly highlights a clash with the ceiling contractor who is scheduled to arrive next week.
Right, mathematically, the software provides the perfect radar for that cargo ship we talked about earlier.
So mathematically, the moderation exists. The tech can spot the iceberg.
Yes. And this is a big but the humans on the ship don't know how to look at the radar screen.
Precisely. The qualitative data and the conclusion reveal that the raw implementation on the ground is failing to reach this potential. The industry is buying the software, but they aren't changing the culture.
It reminds me of a hospital buying a $10 million state-of-the-art MRI machine.
Oh, that's a good analogy.
The hospital board approves the budget, they plug this glowing, beautiful machine into the wall, and they pat themselves on the back for being a modern facility.
Right.
But they completely forgot to hire a radiologist who actually knows how to read the scans. Or worse, the senior doctors are stubborn and insist on just using their stethoscopes because, that's how we've diagnosed patients for 30 years. You have the technology, it is fully capable of saving lives, but without the institutional readiness, the training, the behavioral shift, the willingness to adapt, that MRI machine is just an incredibly expensive, glowing paperweight.
That is the exact dynamic occurring across the GCC construction sector. Governments and massive semi-government clients are mandating BIM. They write into the contracts that the contractor must deliver a digital twin of the project.
A digital twin.
Yes. But if the bureaucratic culture remains deeply reactive, it falls apart. If the C-suite buys an AI scheduling tool, but the subcontractors on the actual site are still tracking their daily progress on a piece of doot-smudged paper that gets lost in the back of a foreman's pickup truck.
The digital system starves.
Exactly, because the AI is only as smart as the data you feed it.
Right.
You cannot simply mandate artificial intelligence and expect systemic, deeply rooted institutional delays to vanish overnight. The technology only amplifies the existing process.
Meaning what?
If your process is well-planned and highly coordinated, the technology accelerates your success. But if your process is broken, uncoordinated, and reactive, the technology just gives you a faster, more detailed view of your failure.
Wow. A faster, more detailed view of your failure.
Yeah.
That is a sobering thought for any project director about to write a massive check for a new software suite. You are basically just paying to watch your project crash in high definition.
It is a harsh reality, but it is exactly what the data suggests when you lack behavioral readiness.
Which transitions us beautifully from the regression lines and the beta coefficients into the actual human voices of this study.
The qualitative part.
Yeah, the researcher didn't just crunch numbers. They asked these 124 professionals open-ended questions. I want to look at those qualitative insights because they really ground the statistics in the gritty daily reality of the site.
The qualitative insights are essential for triangulating the data. When asked about the most significant challenge to timely project delivery, a massive 57.9% of these seasoned professionals cited unpredictable external factors as their biggest hurdle.
Right. They aren't blaming the crane operators they are pointing outside the fence.
Exactly. They're talking about economic instability, shifting geopolitics, sudden regulatory changes, and unpredictable updates to labor laws.
And this completely validates the institutional theory framework we discussed at the very beginning.
It does. The practitioners are explicitly telling us that the ecosystem outside the construction fence is often far more disruptive than what happens inside it.
What specifically did they point to?
They specifically identified client-side delays, excessive design changes mid-construction, and agonizingly slow authority approvals as the true roadblocks across the UAE, Saudi Arabia, Qatar, and Oman.
I also noticed the survey asked them about contract preferences, and I found this fascinating. The practitioners overwhelmingly favored traditional lump sum and remeasurable contracts over more modern collaborative frameworks. Why is that?
It makes complete sense from a psychological and financial standpoint in this specific environment. In a highly volatile, delay-prone region, stakeholders crave one thing above all else.
Cost certainty.
Yes. A lump sum contract transfers the financial risk of delays and material price fluctuations largely onto the main contractor, while giving the client a guaranteed fixed budget.
But the research also notes that these rigid contracts are a double-edged sword.
Yes, they struggle immensely with dynamic risk allocation. When a massive external shock occurs, say a global supply chain disruption that quadruples the price of shipping steel, a rigid lump sum contract doesn't allow for flexible, collaborative problem solving. It immediately creates an adversarial environment.
Everybody retreats to their corners.
Exactly. The contractor claims force majeure, the client points to the fixed price, and suddenly you have a legal dispute. Work slows down or stops while the lawyers fight it out, which ironically causes the exact delays the contract was supposed to prevent.
So, how do these human perspectives from the field validate the heavy statistical models? Do the stories match the math?
They mirror each other perfectly. In the qualitative responses, there was a desperate recurring demand for early stakeholder alignment and comprehensive feasibility studies.
And that matches the regression data.
Flawlessly. This practitioner demand aligns perfectly with the heavy regression weighting we saw on the very first variable, construction planning effectiveness. The math said that poor planning and blind scheduling were the biggest statistical drivers of delay.
Right.
And the humans in the field grabbed a pen and wrote down that a lack of early alignment and wildly unrealistic timelines were their biggest daily nightmares. The math and the human reality are in perfect harmony.
So what does this all mean? We have diagnosed the disease, we know the symptoms, and we clearly know the limits of both our current management tools and our digital software.
Yes.
How do we fix a multi-billion-dollar systemic failure in the most active construction market on Earth?
The dissertation doesn't leave us hanging. It breaks this down into actionable pathways for two main groups: policymakers and the industry professionals themselves.
Let's start with the policymakers. The government entities and massive semi-government clients funding these megaprojects. What do they need to change?
The research calls for a fundamental shift from reactive to proactive governance. Policymakers need to mandate early-phase risk assessments before a shovel ever hits the ground.
Meaning no more rushing to break ground just to get a good photo op for the evening news while the blueprints are only half finished.
Exactly. The political desire for visible progress cannot override the engineering reality of front-end planning. Furthermore, policymakers should offer financial incentives, not just mandates, for the successful adoption of smart construction tools.
Okay, but remembering the digital dilemma, they cannot just demand the tech.
Right. They need to create regional centers of excellence for digital governance. They must actively invest in training the local and regional workforce to truly operate these digital tools.
Because if they don't, they are just buying more glowing paperweights.
Precisely. They have to build sustainable institutional knowledge, which will also help reduce the extreme reliance on a transient expatriate labor force that takes its experience with it when its visas expire.
And what about the project directors, the contractors, and the site managers who are actually in the dirt running these sites? What is their mandate?
For industry professionals, the mandate is a massive behavioral and cultural shift. They must push for systems-based planning. They have to actively move away from the traditional culture of reactive firefighting.
I know exactly what you mean. In this industry, the hero is always the manager who works 24/7 over a holiday weekend to fix a massive crisis that suddenly erupted on site.
Yes, we celebrate the firefighter. But the research says we need to move toward data-driven, proactive project governance.
So who should the new hero be?
The new hero should be the manager who analyzed the 4D BIM schedule, foresaw the risk 3 months in advance, and quietly prevented the crisis from ever happening in the first place.
That's a huge cultural shift.
It is. Furthermore, professionals must ensure transparent, fearless communication across all stakeholders. They have to collaborate early to cut through the bureaucratic red tape that paralyzes decision-making.
Okay, let's pull all of this together. The ultimate lesson for you, the listener, whether you are navigating the chaotic waters of a GCC mega project or trying to keep a mid-sized commercial build on track, is this. Delays are not just about bad weather, a late shipment of rebar, or an unproductive Tuesday.
They are deeply rooted institutional and systemic failures.
Exactly. The statistics absolutely prove that rushing your front-end planning, flying blind on your scheduling, freezing your financial supply lines, and mismanaging a complex labor force are actively destroying timelines.
And while digital tools like BIM and AI have the mathematical potential to help, they are currently failing to save us.
Right, because the industry simply lacks the behavioral readiness to use them properly. You cannot fix a behavioral, cultural, and institutional collapse with a software update.
That is the crucial synthesis. And if we connect this deeply researched data to the broader trajectory of the global construction industry, this raises a final, highly provocative question for you to consider.
What's that?
The mega projects in the Middle Eastern region, the 100-mile linear cities, the massive futuristic industrial zones floating on the sea, they are only growing in scale and unprecedented ambition.
Yeah, they are getting bigger.
They are stretching the absolute limits of what complexity theory can even model. So what happens to the stability of global supply chains and to international investor confidence if the construction industry continues to obsessively digitize its tools without first upgrading its human and institutional foundations?
That is a scary thought.
If we build trillion-dollar digital twins for projects that are still being run by analog reactive bureaucracies, are we actually advancing, or are we just engineering much more spectacular, expensive failures?
That is an incredible thought to mull over. If the foundation is broken, the skyscraper falls, no matter how much tech you put on the top floor. We started this deep dive talking about that perfect, pristine Gantt chart, that expectation of surgical, engineered precision.
Which rarely survives the reality of the site.
Right. What this research definitively proves is that the X-ray machine is broken. The landscape is murky, the bureaucracy is heavy, and the delays are overwhelmingly systemic.
But by understanding the complex math, the theoretical frameworks, and the human behaviors behind those delays, we can finally stop staring at the fire and actually start designing a better way to build.
Thank you so much for joining us on this deep dive. Take these statistics, take these theories, and most importantly, take that demand for proactive planning into your very next meeting.